Hello, my name is Nick Montaigne. I'm an urban forestry student in the Faculty of Forestry at UBC. As part of the Ecological Connectivity Toolkit, I'm going to be going over my methodology for the web map and web map scene tools. Um, so here we are on the UBC campus, and the green polygons you see are soft landscapes. And soft landscapes are basically any plant or collection of plants in a defined area. So here we are at the Forest Sciences Center. And so my analysis, my ecological connectivity analysis, it's built on essentially the number of overlapping buffers of each of these soft landscapes. So you see now each of these soft landscapes has this green ring around it. That's a 10-meter buffer. And basically what I did is I went into ArcMap and I had which is a GIS software, and I had the program count the number of overlapping buffers for each of these soft landscapes. And I used the tools Polygon Neighbors and the frequency tool in order to achieve that. And I was also able to symbolize each of these soft landscapes as a gradient of high and low ecological connectivity, where the soft landscapes that are greener, the darker green soft landscapes you can see now are the ones that have the most ecological connectivity according to my analysis. And so I'm basing this metric of ecological connectivity. It is off of the number of soft landscape, a number of intersecting buffers for each of these soft landscapes. And my colleague Ben Schäufler was able to take this analysis a step further and project it as a node and link network. So this makes it a bit easier to understand what is being symbolized, or what the connectivity analysis is trying to express to the audience. And so as you can see here, we have these two soft landscapes, and this one right here is darker green because it has more connections associated with it. And again, these connections are based on these buffers, right? So the buffer of this soft landscape has all these overlapping buffers. So that's why it is darker green than the soft landscape right here, because this one has fewer buffers. So we have now the whole UBC campus with the soft landscapes showing the gradient of high to low connectivity. And we have this network now that is essentially the connectivity analysis expressed as a network. And we can also see where the areas of no connectivity are according to my analysis. And so if we turn on this layer, I can see a couple pop up, like the ones right here, or we could go over here, and these big red dots they indicate the soft landscapes that have buffers that are not overlapping with any other buffers. So you see here, this buffer does not have any overlapping buffers. Therefore, this soft landscape has no connectivity. And another way of expressing no connectivity is through what I call and refer to as dead zones in this report. So these dead zones are the areas where the buffers are not present. So say going back to the Forest Sciences Center, we have this dead zone here, which is essentially where the buffers they're not present, right? And so this is important. You can read my report to realize why it's important, but I'll just go over quickly here that these are the areas of extensive gray infrastructure development They're usually just tops of buildings or large areas of concrete. And so those are rooms for improvement in terms of increasing urban forest cover on the UBC campus. And so another way of projecting this soft landscape data, where we have the darker green, instead of having the darker green soft landscapes represent more connectivity, we can have the darker green ones be extruded from the ground, and where the taller ones, the taller soft landscapes are the soft landscapes with more connectivity. So this is a web scene here, and uh, and basically this says importance for ecological connectivity tool. And the reason why it says importance is because um, the tallest soft landscapes here are not just um, based on the intersecting buffer it's also based on a combination of three different factors, and those factors are um, like the one is the intersecting buffer data, two is um, the the tree density, and three is the area of each of these soft landscapes. And so the reason I did this is so that the ecological connectivity metric can be a bit more accurate and representative. Um, and so you, as a user, you can scroll through this and just kind of explore which parts of the campus have high and low connectivity, or which soft landscapes are surprisingly very connected. You know, like the ones over here, like near the UBC garden. Um, so, and yeah, I encourage you to add more data to this connectivity analysis. And you can, I just measured, this is just showing the average of three different metrics that I thought were important for ecological connectivity, which again is the intersecting buffers, area, and tree density. But you can add to that. You could maybe measure, like have a metric for biodiversity, or like functional connectivity. So I encourage you to explore the web map scene and web map tools and see what interests you.